I'm Manish Nasta with Verizon. I have responsibility for commercialization of our public and private mobile edge computing portfolio. I'm so pleased to be here today to talk about the transformational possibilities on 5G and edge. This will truly open up new use cases, new applications, and things that people would be able to do with 5G and edge that were simply not possible today. This will usher in the fourth industrial revolution and really enable the real-time enterprise. Without further ado, let's dive right in. When we think about the edge, it really is the next frontier of digital transformation. We're entering a new era of change and transformation that many call the fourth industrial revolution. Like the preceding revolutions, this one is based on a general purpose technology. So if we go back in time and look at the first industrial revolution, often known simply as the Industrial Revolution, it gave us the basic elements of modern industrial society, such as the steam engine. The second industrial revolution, sometimes called the technological revolution, was based on electric technology and the division of labor. We think about the third industrial revolution or the digital revolution that we've been living through for the last 50 years or so. It's been built on computing technology, including personal computers and the internet. Now we're at the dawn of the fourth industrial revolution. This will be built on highly connected technologies, creating what we call the real-time enterprise. With the fourth industrial revolution, advances in connectivity can enable technologies like virtual reality, Internet of Things, autonomous vehicles, artificial intelligence, and so much more. The foundation of these innovations will be the 5G network and mobile edge computing. Mobile edge computing will what make 5G inherently valuable to businesses as they imagine new use cases to serve their customers better. Now let's look at the shift towards the edge and what does that truly enable? When we think about edge computing and placement of computing and storage resources at the edge, the capabilities that enables include super low latency, where the ability to place the storage resources, computing resources, away from the data centers that are geographically concentrated into the edge of the network will allow for super low latency applications. The ability to gather data where it can be acted upon in near real time and with data sovereignty and security protections will allow for significant edge real-time processing. It will also allow for realization of IoT potential. Now we can take millions of devices and connect them to edge computing resources where real-time edge data processing can be done. This will help to realize lots of new applications and use cases. Now let's look at the critical technologies that enable our 5G future. When we think about 5G, what makes it so special compared to prior cellular networks? So when we think about the different generations, we've gone from 2G to 3G to 4G to 5G. What makes 5G different? We believe 5G built right delivers on 8 different currencies of 5G. Those are throughput or speeds. Speeds we can gather speeds in 5G up to 10 times faster than the fastest 4G LTE. From a data volume perspective, we can connect lots more devices in a given data volume and transfer that data at a much faster speed. From a mobility perspective, we can connect devices and sensors in motion at speeds upwards of 300 miles per hour. From a device perspective, we can connect up to 1 million devices per square kilometer. We can reduce the energy consumption of devices by up to 90% with better design and better efficiency. We can deploy services much faster that keeps the network secure and responsive to business needs. This will also have the reliability that we've come to expect from the latest 4G networks from Verizon. And from a latency perspective, we will decrease data send and receive times from over 80 milliseconds to the cloud to eventually less than 10 milliseconds, making applications more responsive and new use cases possible. Now, not all 5G networks are created the same. Some don't deliver all the 8 currencies, what we call the critical capabilities. And the reason why we think it's critical to deliver on all the 5G 8 currencies is so that we can deliver a much better experience in the marketplace. Now let's look at why these things and how these things are actually enabled. We believe that you need a deep fiber network, really 4 capabilities, starting with deep fiber. It takes many years of testing, planning, innovation, rollout of 5G offering that is capable of delivering on the 8 currencies that we mentioned and really ushering in that 4th industrial revolution. That's one of the reasons why we have spent many years deploying a massive fiber network. Our dense and ever-expanding nationwide fiber infrastructure is supporting almost everything that we do. This investment not only gives us the infrastructure to support expansion of our 4G network, but really serves as the foundation for our 5G ultra-wideband network, which opens up the new possibilities that we're referring to. We've installed thousands of miles of fiber and of our own fiber and leased fiber. We committed a few years ago to over $1 billion of fiber spend with Corning through 2023. That is being actively installed as we speak. And this fiber network is integral to delivering our revolutionary 5G network. The second part of the critical technologies and capabilities that we need to deliver the 5G future is millimeter wave spectrum. We have secured a large portfolio of millimeter wave spectrum through company and license acquisitions over the years. That is to help ensure that our customers can expect the best 5G network experience. Software-defined networks and virtualization. So as SDN, network function virtualization, and other virtualization technologies are being rolled out, they are being rolled out in our network as well that enables us to evolve our network, to do network slicing for customized network experiences, and deploy a service-based architecture. These technologies enable operational agility and customized virtual networks configured to specific customer needs. 5G is all about virtualization. Without virtualization, you can't integrate fully with our software-defined network offerings, and you can't support true compute at the edge for real-time application. And then finally, multi-access edge computing. We have network locations throughout our network on a nationwide basis that are ideally suited to house edge computing resources. Computing at the edge will deliver access to the tools, power, and everything that we need to deploy applications at scale. Verizon continues to invest heavily across all these capabilities that will ultimately deliver upon the 5G 8 currency. So as we think about the capabilities being brought to bear by 5G and edge computing, what do we think will happen? What we think is 5G and MEC will enable the real-time enterprise by providing end-to-end visibility and control from production to consumption. The ability to process data from thousands of sensors with low latency at the edge will allow for real-time control and intelligence with end-to-end security. It will open up new use cases leveraging machine learning, AI connected to devices and sensors in real time, things that were simply not possible to do before. So when we think about use cases, we've thought through use cases in the context of the 5G edge computing, and where that is located. So let's dive into some of those use cases. What this depicts is the use cases that are enabled by the 5G currencies and then enhanced by edge computing. On the far left, we show general purpose cloud that is delivered by any of the cloud providers today. And we step through new use cases as we move the edge cloud closer to the end user network, to the end user location within the network. At the network metro level, where we have service access points, we're able to achieve latencies of 20 to 80 milliseconds. With these types of latencies, you can imagine lots of different use cases. For example, we would be able to provide near real-time visibility into the supply chain as an example. So trucks or ships can be tracked approaching a port, have their paperwork processed, and we sent notifications of where to go off and drop materials, eliminating hours of waiting to be manually received. Another use case enabled is three-dimensional volumetric digital objects. 5G MEC enables massive amounts of raw video to be processed, creating these digital objects in real time, which can then be used for enterprise video collaboration or state-of-the-art marketing campaigns. And finally, another example, we can create immersive shopping experiences by overlaying product information via augmented reality, personalizing digital ads on grocery freezer doors, or directing customers to the exact location of the product they're looking for. Without 5G and MEC, these near real-time experiences would not be possible. Now let's look at as you move the edge cloud even closer to the end user and their location. By moving the edge cloud to our centralized radio access network or the far edge, we're able to drive the end-to-end latencies down from 20 to 80 milliseconds down to 7 to 20 milliseconds. With these latencies, now we enable vehicle-to-vehicle infrastructure interactions of autonomous cars and drones. It truly makes that V2X infrastructure possible. It enables real-time cloud gaming experiences that don't need to be downloaded onto the end device, and cloud gaming can happen in the cloud. We also begin to see a massive reduction of energy consumed by devices, again driving an increase in the number of connections to the network. Finally, when we stand up private networking, private 5G, and MEC networks on site at a customer location, we can achieve latencies that are even below sub 7 milliseconds. With these latencies and added security, we can begin to enable even more use cases. For example, mission critical performance, security, and latency needed to run industrial controls and maintenance commands in real time. Real-time adjustments to an assembly line process to correct any material defects seen through the computer vision analytics. Offloading of complex processes, hardware, storage of devices onto the edge compute infrastructure that's locally located to drastically reduce the cost and increase their efficiency. So what we envision from a use case perspective is developers and enterprises will be able to leverage the multiple capabilities being brought to bear by the combination of 5G and edge computing. And the world is their possibility from a use case perspective. Now let's look at what Verizon announced back on August 6th with AWS. What we did was we launched the first edge computing solution with AWS that enables large-scale application development and critical application latency located directly at the Verizon's 5G edge network. Essentially, we've moved the centralized cloud, the resources from the centralized cloud, computing and storage resources, to Verizon's network edge at the 5G edge. This is called AWS Wavelength. We announced that back in August, and we are already off to the races. We announced in 2 different cities, the Bay Area in California and Boston, Massachusetts. Since then, we've announced 3 more cities. We've announced in Atlanta, New York City, and DC. There are up to 5 cities launched for this year, and the intent is for us to launch up to 10 cities. This will enable developers and enterprises to develop the applications and use cases that leverage the capabilities of 5G and MEC directly on Verizon's network. There will be no reason for the end devices, the sensors, to actually traverse the internet. They will have direct access to edge computing resources through Verizon's network. And to illustrate this, what we have is a couple of use cases that we've come up with. When we launched back in August, we came to the table with a company called Avacia Systems. And Avacia Systems is developing a artificial intelligence, machine learning-based inference model that does some really cool stuff at the edge. Their particular application helps doctors to conduct colonoscopies at an endoscopy center with more accuracy and better assistance than they could have without being able to process the data at the edge. So let's look at the video.
Hi, I'm Raj Nair. I am the co-founder, chief scientist, and acting CEO of Avesha Systems. We build a platform for accelerating edge applications. The trial we're doing with Verizon and AWS is about using AI to help endoscopists more accurately detect polyps in real time.
I'm Dr. Shannon Scholl. I'm a gastroenterologist in Raleigh, North Carolina, and a physician owner in Raleigh Endoscopy Center. One of the problems that gastroenterologists like myself face is finding these very subtle polyps. The purpose of this trial is to use 5G, AI, and the edge to put another set of eyes on that. Colonoscopy moves very, very fast, and I really need a computer program to keep up with me. I can't wait 2 to 3 seconds. So the really vital thing about this technology is the speed.
It works by taking the video feed from the scope, sending it through the 5G network to the wavelength node, where the AI model is trained for identifying different types of polyps. And the results are then sent back in real time to the monitor of the practitioner.
So what you're seeing here is the actual high-def monitor that I'm looking at during a colonoscopy procedure. And the neat thing about this program is that it's drawing bounding boxes around this polyp in real time. And they really draw my attention to this sort of pale, flat polyp that's trying to blend into the background. Might not have otherwise seen this.
The system, if it is not fast enough, will actually miss drawing boxes around the polyps in real time. And that's why you need Verizon's 5G and AWS wavelength to give you that low latency.
The thing that really excites me about this technology is that I think it's going to be really important in the prevention of colon cancer. It improves accuracy in patient outcomes. It's going to be the standard of care, and it's going to be accessible to everyone, and that's good medicine.
Now let's look at another use case. We partnered with a company called DD Sports that has a particular application called Shot Tracker that embeds sensors in basketballs as well as in player jerseys to deliver real-time statistics and analytics for a better coaching and a fan experience.
Hi, my name is Davian Ross, and I'm one of the founders and president of DD Sports, and our basketball product is called Shot Tracker. Shot Tracker is a sensor-based technology that tracks statistics and analytics, providing real-time data to coaches, broadcast partners, fans, and players, all with sub-second latency. Basketball is constant activity up and down. Latency is so critical. One thing that we're doing that's really exciting is demoing our Shot Tracker technology over Verizon 5G and AWS wavelength. This allows us to see the delta between the traditional process, which is 4G, and this accelerated, amplified process that utilizes both 5G and MEC. You can distinctly see the difference in the speed of ball movement. When I think about what 5G and edge computing can do, I think about coaches. I think about them getting access to this video and data anywhere in the facility. It may be in the locker room at halftime or sitting on the bench during the game, all delivered in real time. When you think about being able to take this data and incorporate it into the broadcast, latency is even more important. We're really excited about what 5G and MEC will provide to the market. We've been waiting on this for so long, and the time is now. It's finally here. And it will revolutionize the fan experience, the viewing experience, and how we consume data and sports for the rest of our lives.
Great. So in closing, as we think about the fourth industrial revolution, it really is the deep network expertise and investments that we are making in deploying 5G right, in partnering with companies like AWS to bring the tools and services of cloud computing right to the edge of the network. And then partnering with companies like Avesha and Shot Tracker to build new use cases that were simply not possible without the capabilities of 5G and MEC. We think that we're truly at the cusp of the fourth industrial revolution, and 5G and MEC capabilities will be helping us power those. Thanks so much.